Inertial confinement fusion is a type of fusion energy research that attempts to initiate nuclear fusion reactions by heating and compressing a fuel target, typically in the form of a pellet that most often contains a mixture of deuterium and tritium to compress and heat the fuel. Energy is delivered to the outer layer of the target using high-energy beams of laser light, electrons or ions. Although for a variety of reasons, almost all ICF devices as of 2015 have used lasers. The heated outer layer explodes outward, producing a reaction force against the remainder of the target, accelerating it inwards, compressing the target. This process is designed to create shock waves that travel inward through the target. A sufficiently powerful set of shock waves can compress and heat the fuel at the center so much that fusion reactions occur. The energy released by these reactions will then heat the surrounding fuel. And if the heating is strong enough, this could also begin to undergo fusion. The aim of ICF is to produce a condition known as ignition, where the heating process causes a chain reaction that burns a significant portion of the fuel. Typical fuel pellets are about the size of a pinhead and contain around 10 milligrams of fuel. In practice, only a small proportion of this fuel will undergo fusion. But if all this fuel were consumed, it would release the energy equivalent to burning a barrel of oil. ICF is one of two major branches of fusion energy research, the other being magnetic confinement fusion. When it was first proposed in the early 1970s, ICF appeared to be a practical approach to fusion power production, and the field flourished. Experiments during the 1970s and 80s demonstrated that the efficiency of these devices was much lower than expected, and reaching ignition would not be easy. Throughout the 1980s and 90s, many experiments were conducted in order to understand the complex interaction of high-intensity laser light and plasma. These led to the design of newer machines, much larger, that would finally reach ignition energies. The largest operational ICF experiment is the National Ignition Facility in the US. Designed using all of the decades-long experience of earlier experiments. Like those earlier experiments, however, NIF has failed to reach ignition and is, as of 2015, generating about one-third of the required energy levels. As of October 7, 2013, this facility is understood to have achieved an important milestone towards commercialization of fusion, namely, for the first time a fuel capsule gave off more energy than was applied to it. This is a major step forward. A similar large-scale device in France, Les Megajoule, was officially inaugurated in October 2014. Experiments have started since then, albeit with low laser energies involved.